All right, when converting complex numbers to trigonometric form, that means you're taking a complex number, which means in this form here, a plus bi. Here's some examples of what we would call complex numbers. And that just means that they are being displayed visually or graphed in the plane, the complex number plane, which means this is our real number axis and this is our imaginary number axis. So a number like 2 plus I is essentially saying from the origin we go to the right 2 and up 1. That's like 2 plus 1i. So when you are converting this to trig form, that means you need to find r and theta that are specific to that number. And you can see in this little graph, r is essentially just the hypotenuse of the right triangle that's formed, and theta is the angle there. So in this first one, r is just going to be a squared plus b squared equals c squared. So we're going to get an r value of the square root of 5 times the cosine of... Now this first one, we actually need to figure out what theta is by doing any sort of trig inverse function. You could just do the tan inverse of 1 over 2 and keep it in radian form. Typically, you kind of need to know how to go back and forth between radian and degrees, but we're going to keep it in radian form. So in this case, that's going to get us a radian value of 0.464 plus I times the sine of 0.464. Now, a lot of times this will be written in a shorthand where r times cosine theta plus I sine theta is just written as r cis theta. In this case, that would just be root 5 cis 0.464. Once again, this is just theta in radians. In our other examples, I chose numbers that are going to give us more what I call unit circle angles. In this next one, 4 minus 4i, that means I go to the right 4 and then down 4. So we're going to have a 45, 45, 90 triangle. You can still use Pythagorean theorem to find r, or if you know your special right triangles, you'll know that that makes r, in this case, 4 root 2. Right? We just multiply the legs by root 2 to get r. Times, now theta, you can either express theta as this angle here, or you could say this negative angle right here. We're going to keep them positive for this video. We know that's 45 degrees or pi over 4. So that means this theta value is going to be 7 pi over 4. So we're going to have cosine 7 pi over 4 plus I sine 7 pi over 4. Now, these are considered equivalent values. If I literally found the cosine of 7 pi over 4 and I times it by 4 root 2, and then I found the sine of 7 pi over 4 and times it times 4 root 2i, I would get 4 minus 4i. So it's just expressing the number in a different way. It's useful for things like de Moivre's theorem and the theorem on nth roots, which are in other videos. Let's just look at a couple more quick examples how to do this. -1 plus root 3i, 1 over to the left, up root 3. That number is going to be right there. That's a typical 30, 60, 90 triangle. So we know this right here is 60 degrees. That makes theta 2 pi over 3 and r r is 2. So if we were writing it in the shorthand method, that would look like 2 cis 2 pi over 3. Once again, that really just means 2 times cosine 2 pi over 3 plus I sine 2 pi over 3. Last, here's an example where a is 0. You could have sometimes a or b is 0. Negative 6i, that would mean you're just down 6 on the vertical axis, the imaginary axis. These ones are pretty easy. R is just going to be 6. That's what the distance is from the origin. That's really what R is in all these cases, is the distance from the origin. In this case, R is 6 and theta is 3 pi over 2 or negative pi over 2, however you want to do that. So we would express this as 6 cis 3 pi over 2. And again, if we were writing that out in the long form, that would just look like 6 times cosine 3 pi over 2 plus I sine 3 pi over 2. All right, so that's simply just how you're converting complex numbers to what we call trig form. Really, it's only useful when you're, again, working with things like Demoivre's theorem and the theorem on nth roots, and taking numbers like these. What that means is taking a complex number and raising it to a power. It's typically easier to work with the trig form of that number to find that solution rather than using the complex number itself. So that's it.